Hi, chemistry students. Mr. Tro coming to you from Buffalo Grove High School. Today we're going to look at exploring what happens when we mix different liquids of different densities together. We're going to try to make a density column here at school, and then hopefully, if you can find the materials at home, you're able to make your own at home. So, what do you say we get cracking? Here we go. Dun, 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 dun. So we're going to head into the neighboring lab, where I have all the materials set up for the lab. Now, if you look, there are 4 different liquids here. We've got a red liquid, a yellow liquid, a blue liquid, and a green liquid. I'm not going to tell you what the liquids are, but just trust that I made these 4 different liquids to be different densities from each other. And what we're going to do now is, after, of course, you have completed the pre-lab portion of the lab, we are going to systematically mix all the different colors together. You can see that there are 6 trials in your data table, and we have 6 test tubes set up to receive those trials. So the order in which I mix them is going to be random, but we're going to make sure, for example, that red mixes with the other 3 colors, and that yellow mixes with the other 2, and that blue mixes with green, and we'll get all 6 together. Okay? So your job as we go through is to observe, write down the 2 colors that we're mixing, and then make observations as to which color is on the top in the column and which color is on the bottom in the column. Okay, let's get started. Okay, so for our first mixture, I'm going to put red with yellow. So in your data table, go ahead and write down color 1 is red and color 2 is yellow. Now the first liquid, I'm going to squirt in there very quickly because there's nothing else. The second liquid though, I'm going to use this plastic pipette. Now you don't have plastic pipettes at home. We have them here at school, so later on in the lab when you have to do this at home, you might have to come up with a different type of substance. Now I'm going to add it very slowly on an angle, because I don't want these 2 liquids to mix up. There we go. And hopefully you're able to see which color is on the bottom. Okay, so make observations. Next, let's do red again. And let's do blue this time. Okay, so there's my red. I'm going to put the blue in nice and slow. And there you have it. Okay, so the only color we haven't mixed with red yet is green. So for our third trial, let's do red again. And let's slowly add the green liquid. Now the key to this being successful is you have to add the liquid super slow. If I were to just squirt it in very quickly, I would mix these liquids up so much that they might actually just become one mixture. By adding it slowly though, I allow the green liquid to stay as green liquid and the red to stay as red liquid. And there you have it. So there's a view of our first 3 mixtures. Red and yellow, red and blue, and red and green. Let's move on to the next 3 remaining mixtures. Okay, so since we already mixed red with every other color, we're done with the color red. So moving along here, I have yellow as my next beaker. The only colors that yellow hasn't been mixed with yet are blue and green. So systematically, let's do that. Let's put yellow into a test tube. There we go. And let's add blue. So in your chart, we got yellow and we got blue. All right. Very slowly. I'm going to add them together. Now take notice of whether the blue liquid is sinking to the bottom or whether it's staying on top. There you go. And yellow still needs to be mixed with green. So I'll fill my 5th test tube with yellow. And now let's do green. So it's interesting because sometimes when I add a liquid, you can see it kind of run right down the bottom of the test tube and collect at the bottom and push the other liquid up. But sometimes the liquid I'm adding just rests on top. That's obviously because they're different densities. So make notes in your data table, and all while we're thinking which of these two liquids is more dense and which is less dense. Okay, so I'm officially done testing red with every color. I've tested yellow with every color. There's only one color combination that we haven't tested yet. Okay, why don't you take a second and think about what that one last color combination is. So let's do green first. Might as well. Boom. There's green. And let's slowly add blue. So take notice of whether the blue liquid is resting on top or whether it's sliding right through and pushing the green liquid up from the bottom. One of those two things is happening. Okay, there it is. All right, so just a quick summary. You can see that we have red with the other 3 colors in the first 3 test tubes. Then we have yellow with the remaining 2 colors that yellow hasn't been tested. Remember, yellow was tested with red over here. So yellow only had 2 more colors to be tested with. And then blue and green in our last test. So make sure, looking at these, make sure your data table is checked off. Not checked off, but you have the colors written in and you say which color is on top, which color is on the bottom. Okay, so now that we've done that experiment, the part comes for you now to decide by looking at the data table, think of how the liquids are in terms of density. Try to order them from most dense to least dense or least dense to most dense. Try to put them in order. And your goal as you move on to page 2 of this lab is to make a prediction. So what you're gonna do now is you're gonna take a few minutes, your teacher's gonna give you a few minutes to think about all the data that you received from the video, and you're gonna make a prediction as to if I were to add all 4 of these liquids together in one test tube, how would they stack up? So on page 2 of your lab, Your job is to just label red, green, yellow, blue, whatever you think the order is, label them and make a prediction. And then I'll go ahead and add them all together and we'll see what happens. Okay, so I'm going to go ahead and add all 4 to one test tube. I'm going to use a larger test tube this time because, as you can tell, all 4 might fill up one of those smaller test tubes a little too much. So I'm going to put them in order. Red first, yellow, blue, and green. That's the order we kind of tested things in. Doesn't mean that's the order they're going to stack up in the column, but if density holds true, it shouldn't matter. They should separate into their own layers. Okay, now I'm going to use 2 squirts so that we get a little more coverage. All right. Now, this is going to take a little bit of time, so I'm going to stop talking. I'm going to do it, but I'm probably going to speed up the film for you and show it in time lapse because this might take a couple minutes. Okay, so I've let it sit for a few minutes and you can clearly see all 4 layers. The yellow-blue layer is a very sharp and the blue-green layer is pretty sharp divide. Looks like there's a little bit of a blur between the green and the red, where there's a spot where maybe the green and red liquid mixed a little bit. But you can clearly see the 4 different density of liquids. Okay, so now for part B of the lab, we're going to take a certain liquid, we'll just pick one randomly, and we're going to try to get mass data and volume data for that liquid so that you at home can calculate the density of one of the liquids that we used. Okay, so let's go do that. Okay, so we're back in lab, and you can see the same 4 liquids as before. And we have ourselves a graduated cylinder. Now this is a 10 milliliter graduated cylinder. You can see right there, at the very top, it says 10 milliliters. And there are 10 little markings between every milliliter. So we can actually estimate this to pass the 10th degree, or pass the 10th place. So what we're going to do is we're going to take some measurements from Part B, and using that data, you at home are going to be able to calculate the density of whatever liquid we choose. So let's just pick a random liquid. I'm going to pick liquid blue liquid. Okay. So in your table, go ahead and mark blue, and we're going to measure the weight of our empty graduated cylinder. So you can see empty graduated cylinder is 38.56 grams. So go ahead and put that in your data table as the mass of the empty graduated cylinder, 38.56 grams. Now you see we also need to get the mass of the filled graduated cylinder, but we need to know the volume as well. So I'm going to just set this up so that I can add a certain volume of the blue liquid. Now I can put any volume in here I want. So I think I'm going to put 3 squirts. 3 squirts. Give it a little tap. All right, now comes the hard part. We need to read the graduated cylinder. Okay, we're gonna zoom in. So hopefully you can see that the liquid is between 7 and 8. And we have to estimate exactly what the volume is. So remember, each line is worth 1/10. So it's somewhere around 7.5. But your job, I'm not going to give you the value, your job is to estimate the meniscus. Remember, we read the meniscus, the bottom of that curve. So not the top, but the very bottom, kind of where my fingernail is, right here. What would you estimate that to be? And it should be to the hundredths place. So it should be 7 point blank blank milliliters, okay? So make an estimate. Okay, so whatever volume we just recorded, or whatever volume we just read, should have been put as the volume of our liquid added to the graduated cylinder. Now I'm going to put the filled graduated cylinder on the scale. And you can see that the mass of the graduated cylinder with the liquid is 46.86 grams. It's bouncing between, but it wants to settle on 46.86 grams. So now you should have everything you need in order to calculate the density of our liquid, of our blue liquid. We have measured the volume, and you should be able to determine the mass of just the blue liquid based on the 2 other mass measurements that we made. Okay, so your goal here in part B is to ultimately try to use the mass and the volume of our blue liquid to get the density of the blue liquid and to answer some questions about it.